Okay, hi everybody. This is using implicit differentiation to actually write equations of a tangent line. So we're going to look at example number 1. If you notice, we have the y minus xy squared plus x squared plus 1 is equal to 0. So we are going to use this with implicit to write that tangent line. Now the first thing we want to do is to find a point on the graph where we can have this equation, and the first thing it gives us is x is equal to 1. So what we have to do is to find the y value. We are going to plug the x equal to 1 into the equation and see what happens. So we have the y, we have the 1 for the x, we have the 1 for the x, plus 1 is equal to 0. So if you notice, we end up with that 1 and the 1, that ends up being a 2. So we could write this quadratic. We could take out that negative. We would have y squared minus y minus 2. And if you notice, this factors to this, which gives us a solution of 2. And a solution of negative 1. So what does that mean? It means we have 2 points. So our x was 1, the y is 2, the x was 1, the y is negative 1. So we're actually going to have 2 equations of 2 tangent lines at those 2 sets of points. Next step. Use implicit to find the derivative, because that's what we're going to have to do to turn around and find the slope. Remember, anytime we have a derivative and we have a value, we can calculate the slope of that tangent line. So let's go ahead and write the function again. Y minus x y squared plus x squared plus 1 is equal to 0. We are going to do the derivative by using the dy with respect to x and the dx with respect to x. So here we go. So the very first term is just y. So that just ends up being dy dx. The second part here, everybody, take a quick look. This is going to be a product. So we're going to write out with some brackets because we're subtracting that whole product. So the left times the derivative of the right, and since we have the d, we're going to have derivative of the y, we're going to have the dy dx, and then we have the right plus the derivative of the x. If you notice that is 1, and then the x squared is going to be a 2x dx dx, and the 1 goes to 0. We're just left with this. So, and if you recall, the dx goes to 1. We have it over here as well. So just to clean this up a little bit, we have dy over dx, subtract the 2xy dy dx, and subtract the y squared, and we have the plus 2x is equal to 0. So everything to the right except the dy dx. So those need to go to the right, and we're gonna do this in one little step here. So if you notice, we have a dy here and a dy over dx there. We're gonna do the GCF of that. So we have a dy dx 1 minus 2xy, and then the stuff that I crossed off in red, inverse is going to add that and subtract that. So we're getting both of those to the right hand side by using inverse operations. We get this dy dx parenthesis 1 minus 2xy by doing the GCF of the dy dx. So what happens next? Remember, this is multiply. The inverse is to divide all by that. So our derivative of y with respect to x is y squared minus the 2x over the 1 minus 2xy. Okay, so the next thing we are going to do is to find the slope by having the x equals to 1. And remember, we're going to actually find this for 2 points. We're going to find this for 1, 2. Let's just do that one first. So we're plugging that into the derivative. And our y squared, we're plugging in that 2 minus 2 times the x value, all over 1 minus 2, the x value, and the y value. What do we end up with? 4 minus 2, we get a 2. 1 minus 4, we get a negative 3. So that is our slope for the point 1, 2. For this one right here, all of that is just for the 1, 2. Now we are going to do for the point 1, negative 1. So our slope, by plugging that in to the derivative, we have negative 1 squared for the y minus 2 times the x value, all over 1 minus 2. The x value is 1. The y value is negative 1. What do we get with that? 1 minus 2, negative 1, over 1 plus 2 is 3. Okay? So those are our 2 slopes for the 2 different points. So what we do next page, look, negative, is write the equation of the tangent line. Okay, got this lined up. I'm not sure if it's exactly straight across here, but here we go. So we had for the point, what was the point? 1, 2, and our slope was negative 2 over 3. So here we go, just using point slope form. If you prefer to use slope intercept form, you can. So what would we get with this? Y is equal to negative 2/3 x. What do we get? A plus 2/3, and we are adding the 2 from the other side. So we get y is equal to negative 2/3 x. Let's see, what would that be? 6 8/3. And for the other point, 1, negative 1, we're going to plug all this in. Oh, what was its slope? Negative 1/3, or was it positive? So we have our y plus 1 is equal to negative 1/3 x minus 1. We would get negative 1/3 x plus 1/3. We're subtracting the 1 from the other side. Negative 1/3 x. Let's see, what do we get? Negative 2/3. That's it. See you next time.